Today we are investigating the divergent boundary. Divergent plate boundaries move apart. Okay? Make sure you include arrows showing the direction of the plates moving away from each other. They are separating. And the most common place that because we typically see those features in the ocean at the mid-ocean ridge, we know that the most common type of crust with a divergent boundary is two oceanic plates, or an ocean-ocean boundary. Now the divergent boundary spreads the entire Earth, forming mid-ocean ridges all across the major oceans. You can see here on the rotating Earth them highlight a little bit as we roll around. The two that we are most acclimated with are the mid-Atlantic ridge running here through the middle of the Atlantic Ocean, as well as the East Pacific rise running through the Pacific Ocean. Now, as we know, these plates slowly move apart because of the mantle coming up at the mid-ocean ridge. Again, mid-ocean ridge being one of the main features of this type of boundary. Because of the magma coming up at the mid-ocean ridge, we know we are creating brand new oceanic crust there in the form of basalt. Right? As that magma moves up and comes out of the ridge, we see the rocks on either side slowly separating over time. This continues to happen, pushing continents on either end further and further apart. Over time, as the plates grow, we start to get those features we pointed out in the ocean, having the mid-ocean ridge in the middle, Rift Valley, of course, in between the mid-ocean ridge, the ocean basin, continental slope, and shelf. Rift Valley, again, being the spot where the magma is reaching the surface underneath the ocean. Wherever we have the mid-ocean ridge, we also can expect to see the Rift Valley. Because we have crust moving, earthquakes are usually prominent. As that magma is pushing its way up through the earth, we typically tend to see earthquakes in this area, shallow, right along the boundary. And you can see on our earthquake map here easily where the mid-ocean ridges are within the ocean, right? Those earthquakes stay pretty apparent right along the main boundary line at a shallow depth as that magma comes through the thin oceanic crust. Now the spread of the mid-ocean ridge varies around on Earth. We can see the different rates here. The fastest mid-ocean ridge.
Josh Flink, please report to Dr. Conboy's office. Josh Flink, please report to Dr. Conboy's office.
Is the East Pacific rise, moving at about 7 centimeters a year, where the mid-Atlantic ridge is a little bit slower, maxing out at about 2.5 centimeters a year. So some common places in the world that we find these divergent boundaries, as we mentioned, are all throughout the middle of the oceans. Both the Atlantic and the Pacific are common, but it's definitely spread out to all oceans. Okay, now divergent boundary can also occur between two continental plates, where we have continental crust separating from continental crust. We call this divergent CC, or divergent continent-continent. The motion is still apart. We do have a few different features in this type of boundary. Okay? This type of boundary starts to occur as molten rock starts to rise up from underneath the crust in the asthenosphere and slowly starts to create a bulge across the Earth's surface. This bulge then starts to break, fracture, fault, as that magma starts to reach the surface, and our Rift Valley then occurs. Okay, over time, as that magma continues to push up, the Rift Valley continues to sink and expand as that magma rises to the surface. The crust at that time is still moving apart. Over time, as that Rift Valley expands and continues to lower in depth, water starts to accumulate there, and we often see a big lake or a sea begin to form. East African Rift is the most common divergent continent-continent boundary. Over time, it has started to fill in with water now known as the Red Sea.